In this video, I am going to revisit the example of looking at an object that's underwater, that is to say in a medium of a different index of refraction, and asking the question, how deep does it appear to us? This time I will do this a little more formally, using symbols rather than the numbers that are shown in this example. Let us call x the horizontal distance to the chest. Let us call d the actual depth of the chest. Let us call d prime the apparent depth of the chest. As we said earlier, this is found by taking the ray of light that's in air and continuing it in a straight line. So this is d prime the apparent depth. Using trigonometry, we can say that tan theta 2, where theta 2 is the refracted angle, is equal to x over d, and tan theta 1, where theta 1 is the incident angle, is equal to x over d prime. The incident angle is where the image is found, and the refracted angle is where the object is found. Taking the ratio of these two gives us tan theta 1 divided by tangent theta 2 is equal to x over d prime over x over d, which is equal to d divided by d prime. But what do we do next? We want to use Snell's law. N1 sine theta 1 is equal to N2 sine theta 2. So what we get is sine theta 1 divided by sine theta 2 is equal to N2 over N1. What we have is two different relations, one for the ratio of the tangents of the angle, one for the ratio of the sines of the angle. But we can now make an approximation. We make what's called the small angle approximation. At very small angles, the tangent of the angle and the sine of the angle are approximately equal. So for theta small, tan theta is approximately equal to the sine of theta is approximately equal to the angle itself when expressed in radians. For small angles of incidence and therefore small angles of refraction, we can replace tangent theta 1 over tangent theta 2 by approximately sine theta 1 over sine theta 2. But now let's look at these two relations over here. If we replace tangent theta 1 over tangent theta 2 by d over d prime, and if we replace sine theta 1 over sine theta 2 by what we get from here, n2 over n1, we get finally n1 multiplied by d divided by n2 is equal to the apparent depth d prime. Or in other words, the ratio of the apparent depth to the actual depth is equal to the ratio of the indices of refraction of the two mediums, the one you're in looking at the object and the one the object is in. So if you're in a medium of lower index of refraction, that is to say if n1, the medium you're in, is less than n2, d prime, the apparent depth, is going to be less than the actual depth d. However, if you're in water looking out, so if you were in a medium of higher index looking at a medium of lower index, the object would appear to be further away than it actually is. This is illustrated in the next slide.